an intro. Okay, hey, so I wanted to make a quick video for you guys before we dive into Chapter 8. Chapter 8 is all about sampling distributions, and sampling distributions are going to be the foundation of what we do in Chapter 9, 10, and 11. So it's really important you understand them. It is a little abstract, and so that's why I'm hoping that I can help you understand it before we get into it, okay? So what I want to show you first is, maybe you remember seeing this from when you were in class. This is a little, I was going to say bowl, but a container full of about 15,000 beads. That's a lot of beads, right? Now, these beads are either blue or red. Now the question is, what proportion of the beads are blue? So what I'm going to do, and hopefully you can see this, is I'm going to take a sample of size 10. And I'm going to write down on the board what proportion of those are blue. Okay? So let's start, and hopefully again I'm in the screen here. I'm going to do my first sample, and if you can see that, only 2 were blue. So I'm going to come over here and say 2 out of 10 were blue, put a little dot. And then I'm going to do that and say, well, maybe that was just an unlucky sample. Let's do that again. So I mix it up. And, oh, look at that one. On this one, only 1 was blue. So I'm going to come over here and do 1. Say, well, maybe that was a really unlucky sample. Let's do that again. So I'm going to mix it up again. Do another sample. And in this one, we had 3 were blue. Now, pause. We're getting different results. Is that okay? And yes, that's called sampling variability. We expect to have different samples from sample to sample. But what the idea of the sampling distribution is asking, what would happen if I took all possible samples of size 10? Would we start to see a pattern? In particular, what would we notice about the shape of this sampling distribution, the center of the sampling distribution, and the spread of the sampling distribution? Because if I were to go and take more samples and kept just going and going and going and going, I'd be putting a lot of dots on this board, and we'd be looking for pattern. Again, what's the shape, center, and spread? And you're going to learn some cool stuff in this chapter about that, and some formulas, because you're not going to literally go through and take all possible samples, but you're going to use the basis of a sampling distribution to help figure out probability. Now, let me actually just show you an example here. There we go. Sorry for the delay. Okay. So, again, we're asking, what is a sampling distribution? Okay, let's pretend this is my population. Okay? Notice, what shape is it? Well, it looks like it's approximately normal. Okay? What I'm going to do is I'm going to take a sample of size 5, and then I'm going to average that out. Okay? So I'm going to take a sample mean here. Now watch this. This is going to randomly choose 5 values from this normal distribution here. 1, 2, 3, 4, 5. Boom. Average those out. Here is 1 sample mean. I just took a sample of size 5 from this and averaged it out right there. Let's do that again. Take 1, 2, 3, 4, 5. Average that out. Boom. Notice this sample mean was different than the other one, and that's okay. We expect that. But what we're wondering is, what if I look at all possible samples here, okay? Will there be a pattern with the shape, center, and spread? I'm going to keep doing this. That one was a lot lower. That one we've already seen before, so we'll just add that on top. Now, if we're doing all possible samples, this is like thousands upon thousands. So what I'm going to do is, let's just do 5, okay? So this is just one at a time, but let's say I'm going to add 5 now, okay? And add 5, and add 5. And what we're slowly building here is a sampling distribution. It would be all possible samples of size 5 from this. Now, this is going kind of slow, so I'm going to do 10,000 samples. And what do you notice? I've now built, or I'm building, a sampling distribution. This was normal. What about this shape? It's also normal. Notice, where is this center at? It's at the center of the population data. So the center of the sampling distribution of your sample means is the same as your population mean. The shape was normal, and so the sampling distribution was also normal. What about the spread? You'll notice this is a lot skinnier, and there's a formula you're going to use that'll help you figure out how spread out this is. Now, this was with sample of size 5. What if we had increased our sample size? What if instead of 5, we had done 20? Now, just have a visual of what we just did. I'm going to hurry and do 100,000. How is this sampling distribution different than the one we had with the sample of size 5? And hopefully you could visually see that it's a lot skinnier, that the bigger the sample size made it so it was a skinnier, the spread was less. If you need to see that again, let me just try to hurry and do that. This was 5, and this was 20. And so hopefully the smaller the sample size, you can see that looks like that. Now, so we saw the shape, center, spread. How is it different if our population isn't normal to begin with? Let's pretend that our population is skewed. This is clearly a right skewed distribution. What's going to happen when I look at my sampling distribution of sample means? That's all possible samples of a certain size. So I'm going to go to 5. Our sample is size 5. What that means, I randomly take 5 and I average them out, and I get that value there. I'm going to do that again. Let's take 5, average it out. There's another one. And I'm building here in this blue, I'm building our sampling distribution. Now, I'm just going to jump ahead. That's what the sampling distribution looks like. Let's look at the shape, center, and spread. What you should notice is that the shape is not as skewed, but it's still skewed. It's not normal yet, but it's getting there, right? The centers are going to line up. The mean here should match the mean here. And you can see the spread, it's a lot less spread out. Now, what will happen if we increase our sample size? I'm just going to jump to 25. That's as big as this one will go. And we're going to take our sampling distribution. Now, the one before wasn't exactly normal. It was still skewed. This one is normal. Even though its parent function was not normal, the sampling distribution will be normal if our sample size is large enough. What large enough means, usually we say it bigger than 30. Okay? 25 was large enough here that it made it normal, but usually to be safe we say around 30. But this is called the central limit theorem. The central limit theorem says if our parent function is not normal, but we take a sample size large enough, then our sampling distribution will be normal. And we like normal because then we can do norm CDF on our calculator. We can use table A and figure out probabilities. Now notice, the center matches up with the center from before. So the mean of the sampling distribution of the sample means is the same as the mean of our population data, our population mean. Now, what if we have something that's really weird looking? This is definitely not normal. What we saw in the last one, the central limit theorem says that if our sample size is large enough, that our sampling distribution will be approximately normal. So let's try this out. First, I'm going to do sample of size 5. What will the sampling distribution look like? So just let's see what 1 would look like here, okay? I'd go and I'd take 5 and I'd average them out. And if I got the sampling distribution, does that look normal? Not at all. But that's because our sample sample size was small, is only 5. If I jump that up to 16, that sampling distribution is looking better. Okay, it's still not perfect. Watch this. If I go to 25, that's our normal population. Notice, shape, even though the parent function wasn't normal, our population data wasn't normal, as long as the sample size is large enough, our sampling distribution of sample means will be approximately normal. The center of our population data is the same as a mean of our sampling distribution of sample means. And the spread is going to get skinnier the larger our sample size is. Alright, I hope that's a good introduction to sampling distributions. 8.1 is all about sampling distribution of sample means. So watch the video that goes through the notes, do the examples, and I hope it makes more sense that when you hear sampling distribution, you're thinking all possible samples of a certain size. And remember, the central limit theorem is going to teach us that as long as the sample size is large enough, that the sampling distribution will be approximately normal, which we like because then we could do norm CDF. Alright, good luck, and if you have questions, let me know.